Swayam Prabha. Digital India. Educated India.
In this module, we will look at the solutions of the revision paper, the second revision paper. I hope you've been able to solve these. These are actually, the questions are all related to whatever we have done in the course, and so we'll just go over it quickly. The first question is comment on whether the following goods, services, bads are rival, non-rival, excludable, non-excludable, public, private. Explain your answer. And so we'll start with the first one, a biogas plant. So when you look at a biogas plant is manufactured by a company, it is supplied, it is sold at a price, and if someone uses the plant, it will not be available to someone else. So basically, this is very clearly, this is going to be rival as well as excludable. It is sold only once a price has been paid, and so this is very clearly, this is a private good. Let us look at the next one, the Eastern Freeway. The Eastern Freeway is a road in the city of Mumbai connecting the suburbs to the main hub, then going all the way up to CST, and this is a freeway, there is no toll being charged. So in the sense, now in this case, in the case of a road, if there are many cars coming on it, there would be congestion. So if we say that there is no congestion, then this will be non-rival. Someone using the freeway does not affect the ability of someone else to use the freeway. If you think of congestion, then it could be rival, and since it is being made free, it's non-excludable, and this can be treated as a public good. We could change the rules, and if we have toll, then it is excludable. If we are looking at congestion, then it could also be rival. But in this case, we can consider it as a public good. C is urban air pollution. This is a big problem in most cities in India now. And if we look at this, in a sense, someone's breathing the polluted air does not affect someone else's ability to breathe that polluted air. So essentially, this is non-rival, and generally this is also going to be non-excludable. Of course, now people are putting air purifiers and looking at ways in which one can actually remove this, so that could change. So this is what is a public bad, and that is why, since it's a public bad, the normal rules of market are not very good at controlling this, and then we need to have regulation, we need to have different kinds of methods. Now let's look at the last one here. This is cable television. In cable television, this is actually going to be non-rival. And in general, if depending on the bandwidth, if there's no congestion, your watching cable television does not affect someone else's ability to watch it. And you have these set-top boxes, so only if you pay the charge you are going to be able to get the channel, so it is excludable, and this is a private good, though it is non-rival. So with this we look at, so you can just summarize whatever we have done in the course related to private goods and public goods, and these examples illustrate this. So let's move forward with the next part of the question, 1E. And this question says IITs charge 2 lakhs per year as annual fees to students for undergraduate education, while the full cost of IIT education is about 6 lakhs per year. It may be a little more than that, but for the point of view of this question, we just put it as 6 lakhs per year. There is a proposal to recover the full cost of IIT education from the undergraduate students. Consider a society with 1% families containing IIT students. Would the proposal pass the Pareto condition? So currently the students are paying 2 lakhs and the increase in fees would be 6 lakhs. So if we look at a Pareto condition, the percentage of families, the families who are with students who are currently doing the education, they would not be there, their condition, their utility would decrease because they would have to pay an additional amount. So it will clearly not pass the Pareto condition. Others would not be affected, but if we increase this, the existing students their utility would decrease, and hence that would not pass the Pareto. Then the second thing is, would it be based on the Pareto compensation principle? Now the compensation principle would not apply in this case, because possibly with this additional money which is coming in, maybe the rest of the society will have to pay less, but then there is no way in which they can compensate or provide the 1% of students with the difference in this amount. So it will not pass a compensation principle either, not pass the compensation test. Now suppose the next part of the question is, if the society has to pay an equal tax to bear the cost or recover the full cost from the students. So these are the two options. So clearly 99% of the population who would not want to, even though the amount would be less, they would not want an increase in the taxes for education. The 1% would of course say that an equal tax can bear the cost. So from a voting point of view, the solution would, we will get an option where an equal tax to bear the cost will lose and the full cost would be borne from the students because it is only 1%. Now the last part of the question is, provide an economic argument justifying continuing the subsidized fee. So if we look at higher education typically as a public good, and if we look at the products of that education resulting in an enhanced income for society, and every graduate from the IITs, based on the income that they are going to earn over their lifetime and their career, and the taxes that they pay to the government. So from an economic viewpoint, the enhanced ability to earn will compensate for the subsidized fee. The second thing is that in general, they will be also thinking in terms of creating new knowledge and providing an opportunity for all. So that means every individual has this opportunity, and depending on their abilities, they can get through this, and then they can upgrade their abilities, and then they can contribute to society. And in many cases, the graduates would actually also create employment and create. This, of course, is a debatable issue, but in many cases, you will see that a lot of literature talks about higher education actually being a public good, and this is something which benefits society in the long run. So the other option, of course, is to provide loans, but depending on the average income, taking a large amount of loan for education becomes a barrier for several families, and this has an equity impact. Let's move ahead to the second question. The second question is a standard supply demand curve, which we had also solved it in the when we had done that module. If you look at this is a supply curve for coal in a country is given as P is equal to 2500 plus 5Q. Demand curve is given as 8500 minus 10Q, where P is the price in rupees per ton, Q is the quantity in appropriate units, say million tons annually. Plot the supply and demand curves, determine the equilibrium price and quantity. What is the consumer surplus and producer surplus? Show these on the plot. What is an externality? In the case of coal production, list some of the externalities. If the government decides to impose a carbon tax on all the coal sold, that means 500 rupees per ton of coal, show the new equilibrium point. Is the tax efficient? Does it result in a change in the total surplus? What could be the justification for the carbon tax? So let's start with the first thing is let's draw the quantity on the x-axis and price on the y-axis. And if we look at this, the demand curve will be given as, let's take this is DD, this is 8500 minus 10Q, and so this is 8500, and the supply curve is, so let's say somewhere here 2500 plus 5Q. This is the point of intersection. This is the equilibrium quantity, equilibrium price, and these points, this is the consumer surplus, because this is the price paid is P0, but at zero quantity the demand, we are willing to pay so much. So this is the consumer surplus, and this one is the producer surplus. This is consumer surplus, producer surplus. This is the total surplus. So this is what we have done. We can calculate this. Let us just calculate from the equation. Let's put down 2500 plus 5Q is equal to 8500 minus 10Q. So we get 15Q is equal to Q is equal to 6000 by 15, 400 units, let us say million tons or so. What is the price? Price is going to be 2500 plus 5 into 400, sorry, and this comes to 4500 rupees per ton. So we can go back to this and write down this is 4500 and this one is 400. Yeah, this is 850. Okay, so now we've done this, show these on the plot. What is an externality? An externality is basically something which influences the utility of a consumer or the production function of a producer without its own permission. So in the case of coal production, what are the externalities that we have? Well, we have in the mining there would be a lot of dust and there would be a lot of land modification, and there, in the case of there would be also pollution in terms of the both air quality as well as water, and so these are the kind of things. And then the use of coal, when we look at it, we'll have carbon dioxide and we have emissions. So these are some of the externalities, and if the government decides to impose a carbon tax on all the coal sold, incidentally there is already a carbon cess today, and it's probably around 400 rupees per ton. So we've said here, suppose there is a carbon tax of 500 rupees per ton, how would the equilibrium change, and is the tax efficient? So what this would mean is that if you look at the supply curve, for every ton we are adding another 500. So this will now start from 3000 and we would have it as a something which would be should be parallel to this. So now this will be the new point. New point is Q dash and P dash. We can calculate this. Let's calculate it by looking at how much will this be. We can $3,000 now plus 5Q is 8,500 minus 10Q. So 15Q is 5,500. Q is 5,500 by 15, 367 million tons. What has happened is we have now the equilibrium point has shifted and we are now using less amount of coal. The price now is 3,000 plus 5 into 2,100 by 3, which comes out to be 4,833 rupees per ton. So now we've shifted from the earlier case where we had the price of the initial equilibrium point was 400 million tons and 4,500, and this has shifted to 367 million tons and 4833. So, if we go back to the figure that we had, this is 367, this is 4833. Now, if you look at the total surplus, you will see that the total surplus has decreased. Total surplus has decreased. So, the tax of course is not efficient from that point, because the total surplus has decreased from an economic viewpoint. However, the justification is that if we look at the cost of carbon and the social cost of carbon and incorporate that, then you will find that overall there is a benefit, because we are reducing the CO2, and then the benefit to society offsets the loss which is there for the consumers and the producers. And so, the justification for the carbon tax is that we would like to see that we reduce the total CO2 emissions, and then we are trying to give an disincentive for using coal which has a high carbon content. So, this was the calculation for the second problem. Now, let us move on to the next problem. So, here we are looking at, consider a decision being taken in your hostel so that we can invest in a flower garden between two wings. Now, the way this works is that the hostel has a large number of 300 residents, out of which 100 residents are willing to pay a little more. They have a marginal willingness to pay by P is equal to 100 minus 2Q, because they can have a direct view of the garden, while the other residents can, if they are passing by, will see it, but they do not have it from their rooms. So, the 200 residents have a marginal willingness to pay which is less, 60 minus 3Q, where Q is the number of flowering plants and P is the willingness to pay in rupees. Marginal cost of supply of a flowering plant is constant at 150 rupees. So, at 150 rupees you can buy one plant and then put it in the garden. So, the question is how many plants should be put in the garden. So, we want to sketch the aggregate demand and supply curves and determine the optimal number of flowering plants. And then the question further asks, is this a Lindahl equilibrium? Is this feasible to implement? What are the difficulties in implementing the Lindahl equilibrium? So, now this is a public good, and the supply though is something where there is a price for the supply, but the good of having a garden is something which is non-excludable and it is a private good. But the question is how much of that public good should we be providing. And when we look at this, if we try to sketch this, if we look at the marginal willingness to pay and P and the quantity Q, you will see that the individuals who have a direct view of the garden have a marginal willingness to pay. P is 100 minus 2Q. So, this will go on to when it becomes 0 beyond. So, that will be 50. So, we can just join this. This is the individual demand curve, and there are 100 such individuals. For the other set, those who are not having a direct view of it will start from 60. P is equal to 60 minus 3Q. So, it will go on till 20. And here N2 is equal to 60. The demand, the supply, the curve will be shown clearly as a straight line at 150. Now here what happens is that we aggregate based on the number of potted plants which are there. At any value of Q, we can find out how much people are willing to pay from these two curves. So when it's between 0 and 20, you will have the N2 is equal to 200. So these 200 people will be willing to pay from here, and 100 people. So we can take any point here and just take the values which will be here and multiply. So we will get, if it is at, if 0, let's just write this as if 0 less than Q less than equal to 20, what will happen is the total willingness to pay aggregate demand curve P will be 100 into 100 minus 2Q plus 200 into 60 minus 3Q. So this is 1000, 10,000 minus 200Q plus 12,000 minus 600 Q equal to 22,000, 10,000 plus 12, 22,000 minus 800 Q. So if we look at this, this is the total amount that we are willing to pay. This is going on from, so it will start from 22,000 and then come down when Q is equal to 20. This will be, P will be 22,000 minus 860,000. So this is going to be 6,000. So what will happen here is that when we do this curve, the aggregate curve P, we start from 22,000 and then we go to, when we take 20, let's take 50. In the case of this 22, 10, 6, let's say 6,000. This is the aggregate demand curve. From here onwards, from 20 to the next point, it is only going to be equal to P is equal to 100 into 100 minus 2Q, because all those, the remaining, this set of individuals are not willing to pay anything beyond 20. So it's only going to be this. So when we look at this, this is going to be equal to 10,000 minus 200Q. Now, if the supply price here is 150, so if we put this as 150, then this is going to be equal to 9,000 850 is equal to 200Q, (9850 by 200). So we round it off to the smallest whole number, which comes to about 49. So this, we have a line here which is the demand curve, which is 150, and at around this we go to this. Actually it will intersect almost at this point. So this is, if you draw it proportionately, you will find that this is the value which is there. So this is now the question which has been asked is this a Lindahl equilibrium? Yes, it is a Lindahl equilibrium, because we are asking individuals what is their willingness to pay, and then we are aggregating that. Is this feasible to implement? It is difficult to implement. One is because it is difficult to get the demand curves of the individuals, stated demand curves accurately. There is an incentive to understate the willingness to pay, because you enjoy the quality, but you will pay based on the marginal willingness to pay. So others may get a better share. So basically the issue is, the difficulties in implementing the Lindahl equilibrium is the ability to assess the individual demand curves, and the point that there is an incentive for individuals to understate their willingness to pay, so that they actually end up not paying this. But theoretically, the Lindahl equilibrium is an interesting concept, and there is this whole issue in terms of when we try to price a public good or a public bad. These are the kind of problems. So this is what we have solved in this question.